This is chapter 12, area related to circles. Now, there are various things in our day-to-day life you will see as figures, rectangles, they can be squares, parallelograms, triangles, circles. And we have already seen how to find the parameters and areas of these plane figures. Like parameter is nothing but the boundary length. You start from here, travel, come again, reach this point, this is the length. Area is all this enclosed by the boundary. Most of the things which we see in general life, like wheel, design, washer, cake, or a wheelbarrow, they are of the shape of circle. So let us see in this chapter, we'll try to recall the parameters and areas we have already discussed. And then we will try to recall the sector and segment also, area. And then we will combine this circle with a few of these figures and then see how to find out the parameters and the areas of the resulting figure. Parameter and area of a circle. What is the perimeter? If you start from here and you travel along the boundary and reach here, the distance you have traveled is nothing but the perimeter. And the area which is enclosed by this boundary is the area, or the region enclosed by this boundary is the area. So this is what we call it as a perimeter. We can also call it as circumference in the case of circle. In case of circle, this is circumference. And we have seen in various discussions that the circumference of a circle bears a constant ratio with the diameter, which is the pi. This is the Greek letter pi, pi. So what is this circumference? Take diameter here. Diameter is nothing but 2 into r. So pi into 2 into r, that is 2 pi r. So circumference is 2 pi r for the circle. Well, in fact, great Indian mathematician Aryabhatta, he gave an approximate value of pi. He stated pi equal to 62832 by 20,000. And it was nearly 3.1416. And then the other genius, Srinivas Ramanujan, a mathematician, he calculated the value of pi to million places of decimal. As we have known that the pi is irrational number and the decimal expansion is non-terminating and non-recurring, non-repeating. So for this calculation purpose, we are going to use 22 by 7 and 3.14 for pi. If you want to find out the area, let us just do a small activity. Activity is very small. You have to cut like the cake. You cut the cake in your birthday and just arrange it like this. So how much this area is, we need to find out. So these are all the regions which we have cut and placed it here. This is nothing but the circumference. This is the circumference. And we know that this is a kind of rectangle, as we can see. So this is a rectangle, say this is the 2 pi r. So the side, this and this becomes 2 pi r. This whole means this total is 2 pi r. So this and this combined becomes 2 pi r. So the one side is half into 2 pi r. And what is this radius? Half into 2 pi r into r. So half into 2 pi r into r, that is the breadth and the length. It gives you half into 2 pi r into r gives pi r square. So this is the area. So pi r square of a circle is pi r square of a circle is the area, and the circumference or the perimeter is 2 pi r. This corresponds to circumference C or P, perimeter. Let us see an example. The cost of fencing a circular field at the rate of rupees 24 per meter is 5280. So this is your circular field and the cost of fencing is 5280. So if we have the circumference as 2 pi r, if we multiply this by 24 per meter, it gives you 5280. So if you want to find out the length of this 2 pi r of the fence, you have to divide 5280 by 24. That is what is done. So this is 220. Now 2 pi r is 220. Now we can find out r. Pi is given to be 22 by 7. R becomes 35. Find the cost of plowing the field. The field is plowed at the rate of this. So the area is pi r square. This is pi r square. Pi we have used 22 by 7. The cost of plowing is 0.50. So if you multiply this by 0.50, you will get the cost of plowing the field, that is 1925. The area of the sector in the segment of a circle. This is a circle. If we join these, any of these, or make a region, this blue region, this is a minor sector, this is the major sector, and this becomes the major segment, and this becomes the minor segment. Major segment, minor segment. So this is the minor segment. This part is minor segment. This is the major segment. So once again, if I draw a circle, join any of these, we have two things we need to consider. First is your sector and then the segment. So this is your sector. First, you can say a minor sector. This is your major sector. And this major sector, apart from this, you have this, you combine this, means you just join this. This part is your minor segment, all other is your major segment. And we'll be interested more in the minor segment. So this, let us name, this is your r, radius. Let us take this as theta, and let us take this AB as minor segment. We know that the area of the circle is pi r square, and the length of this, that is the fence, or you can say boundary, or the circumference perimeter, is 2 pi r. So what is the area, this shaded region, or you can say the length of this part or this part? How to find out? It's quite easy. We will use the unitary method like this. That is, for a circle, complete area is what? Pi r square. That is, this from here to here, if we go, we travel 360 degree. So for 360 degree, the area is pi r square. How about theta? For 360 degree, it is pi r square. For 1 degree, it is pi r square by 360. How about theta? For theta, it will be pi r square by 360 into theta. So this is theta by 360 into pi r square. This is the area of the sector. So area of sector is theta by 360 into pi r square, and this theta is in degrees. So you don't have to change. If it is given in degree, you can directly use it. Now again, let us talk about the segment, this part. Okay. Now this complete is 2 pi r. So if we travel 360 degree, the complete is 2 pi r. For 1 degree, it will be 2 pi r by 360 degree. For 1 degree. How about theta degree? Theta degree will be 2 pi r by 360 into theta. So theta by 360 into 2 pi r. This is the length, this APB, length of the arc of a sector of angle theta. So what will be this? This is 90 minus theta, 360 minus theta, sorry. So the length of AQB will be 360 minus theta by into 2 pi r by 360. Okay. And now if you want to find out this region, this blue region, what you have to do? This sector, the area of the sector of OAPB, that we already know, 3 by theta by 360 into pi r square. If we subtract this triangle, that is area of this triangle OAB, we get this region. We'll see how in an example. We'll try to find out. So in this way, the major segment, area of major segment and minor segment can be found out. You just have to subtract it, this pi r square, with area of minor sector and area of minor segment. So what we have seen, let us try to take certain example. We have to find the sector of the circle of radius 4. This is 4, and the angle is 30 degree. We have to find out the area of the corresponding major sector. So major sector. Let us see first method. Then we have another method also. This is another method. This is quite simple, but let us solve by this method so that we understand various complications and the technique. So area of sector is what? We know this area of sector, theta by 360 into pi r square. Theta is 30 degrees, so it will be theta by 360 into pi r square. Pi we have taken as 3.14, r is 4 into 4. So 4.19. And the area of corresponding major sector will be what? The whole complete area is what? Pi r square. So if we subtract this 4.19 from pi r square, we get the corresponding major sector. So just pi r square minus area of sector OAPB, this one, we get the 46.1, that is the area of the major sector. One more thing, this is 30 degree. So how much this will be? 360 minus 30. Why can't we use directly here? Because this is of course theta. So we'll be using this 360 minus theta by 360 into pi r square. This is going to give you the area of major sector directly. 360 minus 30 by 360 into pi r square. R is 4. 46.1 as in the previous case. So in both the way you can use. Now you have to find out the area of the segment AYB, this segment, this blue region. If the radius of the circle is 21 and angle AOB is 120 degree. Angle AOB is 120 degree. So what we have to do is, if we have to find out this region, we have to find out the area of the sector first, and then we have to subtract this triangle from this sector. So the main thing is area of sector is we already know. Area of sector is this pi by 360, theta by 360 into pi r square. So theta is 120 degree. Just place it here. Theta by 360 degree into pi r square, you get 462 centimeters square. So this is the complete area. One thing is clear. Now we are left with the area of the triangle. Area of the triangle. So now let me show you how we'll make it. This is your triangle. This is 120 degree. We'll drop a perpendicular. This is 21. This is 21. So both sides are equal. So this angle will be also equal. This angle will be equal. So we have these two angles equal. These are 90 degree because we have dropped the perpendicular. Sides are already equal, and this is a common side. So these two triangles are congruent. Once these two triangles are congruent, this side, that is this region, this part becomes equal to this part, and this angle also becomes this angle. So this is 60 degree and this is 60 degree. So this is say x and this is x. Okay, so what we have to find out is half into base, that is 2x, into altitude, this h. This and this we have to find out. How we are going to find out? See, it's quite easy. We have known that this is 60 degree, 60 degree. So you can just use cos 60 because this is known. Cos 60 for this is base, means OM, by hypotenuse AM. OM by AM. OM we have considered to be x. So x by 21 is half. So x becomes 21 by 2. This is 21 by 2. This is 21 by 2. Both becomes 21. Right? Again, if you want to find out the this side, no worry about that. What it gives you, OM is 21 by 2. I'm so sorry. This is 21 by 2. This is not 21. We have to find out this. So sin 60, take perpendicular by hypotenuse. Perpendicular is this. Hypotenuse is this. Perpendicular, hypotenuse. This by 21 means AM by OA 21 is sin 60. That is root 3 by 2. So AM becomes 21 root 3 by 2. So this becomes 21 root 3 by 2. This becomes 21 root 3 by 2. So these together becomes 21 root 3. So this is 21 root 3 and this we just got as 21 by 2. Now we can directly apply half into base into altitude, that is 21 root 3 base into altitude. Altitude is what? This is 21 by 2. This is what we have done. So area of triangle is this. Now we just have to subtract 462. We have already found out this complete area. We have just found out the triangle area. So we have to subtract so that we can get this. So this is how we get. We subtract 462 from this, and this is your area of the segment. Now areas of combination of plane figures. This circle can be combined with various figures in various design. There are so many things where we can see. So let us see how to find out the area with few examples. First is you have two flower beds. This is the region it is shown, and you have a square lawn ABCD 56. So if the center of each circular flower bed is the point of intersection of O, then, and these are the diagonals, find the sum of the areas of the lawn and the flower bed. So whole area you have to find out. So area of the lawn is what? This is 56, this is square 56. 56 into 56, this is the area of the circular lawn. Now let us consider this OA small to be x and this also to be x. This is 90 degree because this is square. So x square plus x square will be 56 degree. So x square becomes 28 into 56. This you got. Again, the area of sector means this area. Area of sector is what? This is what? 90 degree. So area of sector becomes what? Theta by 360 into pi x square. X square we have just found out. This x and this x. So this is what? Area of sector OAB. Now this area of sector OAB, here we also have one more. Here we also have one more. So this is one. This is okay. Now area of triangle OAB is what? See. OAB is what? This is 1/4 of this complete area. So 56 into 56 by 4. So this is 1/4 of 56 into 56. What will be the area of flower bed? To compute all these and then subtract the area of triangle OAB. Right? This is what is being done. This is how we get the area of flower bed. Okay. Now we have this flower bed. You can compute the complete area, that is the area of a square and this area of flower bed. 28 into 56, that is the and into 8 by 7, what we have got here, the sides, right? So this is how we compute the complete area. So I am just saying that this is the one method I showed you. What you can do here is, what we have done is we have completed complete area we have found out, and then we have subtracted this area. Okay. Now if you want to total area, this area we have found out, this area we have found out, these two can be found out because the sides are 56 and this is the diagonal. So you can also find out this. This is 56, this is 56. Diagonal also you can find out. 56 plus 56 square plus 56 square under root. This side becomes under root 56 square plus 56 square. If this is found out, half into base into altitude, again half into 56 into 56, this area can be found out. So there are certain methods, various methods. I am not just saying that the method what is being given here is the only method. This is up to you what you choose. But the area of sector needs to be found out because we need to subtract this triangle from this area of sector. So there is an alternative solution. Area of sector, what I was trying to convey is, the area of sector this one, this region, area of sector this region, and then area of triangle this and this. We know that this is 56, this is 56 and this side is half of this. So that is why you can find out the line this by 56 plus 56 square under root and take half and just half into base into altitude, you multiply this area you can get. So this will be 1/4 into 56 into 56. Actually, this is the 1/4 of complete area, 56 into 56. So 1/4, 1/4. You can directly find it out. And area of sector will be 90 by 360 pi, this pi into 28 into 56. Right? So this is quite easy. You can compute it. Now we have to find out the area of the shaded region in this figure, where ABCD is a square of side 14 centimeter. So this shaded region can be found out by subtracting these 4 regions by this shaded region, this complete region. So the area of this side is 14, this is also 14. The complete area is 14 into 14. This is the complete area. How about this? Let us find out the area of 1. We'll multiply it by 4. How much is this? 14. Complete. How much is this? 7. How much is radius? 7 by 2. What is the area? Pi into 7 by 2 whole square. How many circles are there? 4 into pi into 7 by 2 whole square. You subtract this 196, this from 196 you get the value. So pi r square, you have 4 pi r squares and r is 7 by 2. Subtract this, you get the area. One more question is that you have to find out the area of the shaded region here, where ABCD is a square of 10 and the semicircles are drawn with each side of the square as diameter. So this shaded region can be computed like this. You can compute the complete area of the square, that is 10 into 10. Now these are the region 1, 2, 3 and 4. If these can be combined or this can be computed, we can combine these and subtract it from this, we get this shaded region. This is quite simple. So how to get this area? This is the complete half, or you can say a half circle. This is the diameter. So what is this area? Complete area. This is pi r square into half. What is the radius? This is 10, so this is 5. So pi into 5 square into half. Pi r square into half. So the complete area of this one is this. How to get this region? You have to subtract this area. So how to get this area? Now just consider that if let me tell you here, the area of 1 and 3 will not take this 1 and will take 1 and 3. What will be 1 and 3? 1 and 3 will be the area of ABCD, that is area of complete ABCD minus the area of two semicircles of radius 5, which I was trying to explain. Okay, because this is one circle. If you combine these two, this become one circle. And 1 and 3 is nothing but the area of complete minus of this minus of this. Area of ABCD minus area of two semicircles. So 1 and 3 becomes. And in the similar fashion, the other can be found out. Area of 2 and 3 will be similar, 21.5. And when you subtract it area from ABCD, area of 1, 2, 3, 4, this region, you get this area. So what we have seen in this chapter, the circumference of a circle is 2 pi r. The area of circle is pi r square. The length of the arc of a sector with radius r and theta is theta by 360 2 pi r. The area of sector is theta by 360 into pi r square. And if you want to find out the area of this segment, then the sector, the triangle area has to be subtracted from the sector. So this was about this chapter. Thank you so much. Take care of yourself.